Sure. Hello everybody. I'm making this tutorial for lab number 2. So the title of this lab is linear and non-linear devices. So this is the objectives of these labs as written in the manual. Um, you need in this lab you will understand what do we mean by linear or non-linear device. How can you measure? How can you determine if the device is linear or non-linear? Okay. So here in this part, in the first part here in the lab, I'm explaining what is the difference between linear and non-linear device. It's very simple. It's actually all what you have to do. You have to get the relation between current and voltage. That's it. So if this relation, so as shown here in this figure, if this is the voltage across this device and this is the current, if the relation is linear, so we call this device linear device. While if the relation non-linear, whatever how it looks like, if it is non-linear, for example, something like this one, so in this case we say the device is a non-linear device. Okay. So the purpose of this lab is to determine uh, using three devices. You need to determine which one is linear, which one is non-linear. You have to graph. You have to measure the relation between current and voltage, and you have to draw a graph plot like this one. Okay. So actually, what we are gonna do here in this lab is something like this one here, as you see. Number one, you need a circuit like this one. Here you need a voltage source. Okay. By and then you need to find. I will tell you for sure how can you determine the value of this resistor. Okay, and then this part here is actually the device under test. This one here. Okay. So you can see here what is the purpose of this resistor. Just if we use this resistor just to limit the current going through the device under test here. Okay. So by changing the voltage source here, by changing the value of the voltage here, you can actually we're gonna change the current and voltage here. That's exactly what we're gonna do. After you implement the circuit, you have to change the value of the voltage so that you get different values for V and I. Once you get different values for V and I, all what you have to do, as I said before, you have to draw the relation, and then you need to see if this relation is for linear or non-linear device. Okay. So again, we're using only this resistor only to limit the current. So I think I'm writing something to avoid, yeah, so to avoid damaging the component with excessive current. Okay. It's often good practice to have a resistor in series. Okay. So in the pre-lab, you need to design the value of this one. I will come to it. For this device, as I told you in this lab, let me come here. So in this lab, we are gonna use three devices. Number one, resistor, normal resistor. Number two, an LED. Number three, a photo cell. Okay. So for each one of these devices, we call them DUT. So here, the word DUT. So in one experiment, we're gonna put normal resistance. In another experiment, we're gonna put here an LED, this one here. Number three, in the third experiment, yeah, this one. In the third experiment, we're gonna put a photo cell. Okay. So let's come here first. Yeah. So you need to connect this circuit as shown here. This is a voltage source. Okay. In the previous lab, you should learn it. You should have learned how to use or how to connect the voltage source. Okay. So what you are gonna do here, as I told you, you are gonna change the voltage here. By changing the voltage, you are gonna change the current and voltage across, and then you need to record the results in a table. So in the pre-lab, I will show you how can you calculate good value for R, okay, to limit the current, as I told you. So now um, we need we need in order. Okay, again, what do you want to measure? I want to measure the current of this device DUT device under test. Also, I wanna measure the voltage. So that's why I need two devices. I need two GMMS. Okay. So one device here, as you see, is gonna be, I'm guess. Look how this connection is very important. So this is the power supply with this one here. Okay. This one here is actually resistance. This one's the same resistance like this one. And then we are gonna put a meter here. GMM. This one is gonna be used like a meter to measure the current. And then we are gonna connect here a voltmeter, which is parallel to UDT here, to measure the voltage. Okay. However, in the previous lab, we learned only one DMM, so you can use the same DMM we used in the previous lab, but we need one more, right? Yeah. So here, this one more, we're gonna use this one here, which is different from what we had in the previous lab. So this is also a second objective of this lab, is to learn how can we use this digital multimeter. Okay. So as you see here, I give you here, it's called Fluke AT12A DMM. Okay. I give you very important YouTube here. You can watch it to see more how to use it. But it's very easy to use it actually. You can see this button here. You can select between AC or DC for sure, because we are gonna measuring DC. You have to make sure this one is out here. Number two, if you are measuring a voltage, you have to press this one here. If you are measuring a current, so you have to press this one. If you are measuring a ohm or meter, so you have to press this one. Okay. This is a ground. So here, if you are measuring a voltage or meter, so you need to use these two terminals here. If you are using a meter, so you have to use this one and this one here. Okay. Again, there's something really very important, guys, for all labs, because in this lab here we can see we have a power supply, we have um, a power supply here, and we have DMM, and we have DMM here and another DMM. So you can see here the common here has to be connected with the common here. These two common should be connected together, okay, as shown in this figure. Anyway, so here I give you enough information. How can we use this one? For the other DMM, this is the one, I can choose a picture, but this is the one we used. Yeah, let me see here. Yeah, this is the one. Yeah, this is a picture. So in this lab, you are going to use, this is the one we used in the lab, in lab number 1. This is the one used, we are going to also learn how to use it in lab number 2. Okay. So here you need to read this part. I give you some information here. That's what I told you. So if you want to measure voltage, where are the connection? Also, I give you very easy picture to make it things are very easy. So if you want to measure voltage, so you have to. These are the terminals you have to use. You have to press voltage here. Okay. And then you can see, I forgot to tell you here, we have range of values. Okay. So for example, if I want to measure a voltage, so now if you want to measure a voltage so that the maximum value is 200 millivolt or smaller, you can click this one here. If the voltage is 2 or smaller, you click this one here. If the voltage 20 or smaller, you click on this one here. If 200 or smaller, you can click, and so on. Okay. To get accurate results, try to, for example, here, if I want to measure 1 volt, okay, so I can press 200, but it's not going to be accurate, right? 20 is not going to be accurate. 2 is going to be accurate. So try to find the closest range here to the value you are measuring, okay, to get accurate results. Okay. Anyway, everything I think is explained here. This is from here. This terminal should be connected this way. If you want to measure the current, you have to press this one here. Okay. So let me first, because all what you have to do, guys, as I told you, that's it. You have to connect this circuit. So this is DMM used in Lab 1. This is this DMM here, okay? And then you need to, now I'm gonna go to the pre-lab to show you how you should should find the value of R here. And then all what you have to do, you have to change as you will see later, you have to change the power supply here, the value of the power supply. Okay, and then you measure what values you have here. Be careful here because in the past some student recorded the voltage of the power supply. No, we are interested in the voltage across this device and the current through it. Just because I want to know if the relation is linear or not. So let me go to the pre-lab first, because before, yeah. So here in the pre-lab, the first part you have to do in the pre-lab is how can you find the series resistance R? Okay. So here in the very beginning here, I'm telling you, we need to find the value of R to achieve two things. Number one, I want to limit the current to some maximum value. Number two, I have to make sure we're not going to exceed the rated power of the resistor. The resistor you have in your kit is actually 1/4 watt. So I want to make sure we're not going to exceed 1/4 watt. Also here for I want to make sure we want to make sure the current is not going to be more than 50 milliampere. Okay, so now I want to select the value of the resistor to achieve two things. Number one, the current is the current maximum current should be 50 milliampere. Okay, so here so for this part, you have the voltage of the power supply. You have here maximum current. Maximum current should achieve when the device under test is actually short circuit. This is the word. Should give you the maximum current. Okay. So actually, all what you have to do here, you have to use Ohm's law. You have to divide the voltage by the amount of current. This gives you a resistance. Okay. So this resistor can achieve the first objective here, not sorry, the first objective limits the current. Okay, but again, I want to achieve two objectives. So for the second one here, the maximum power, it should be 1/4 watt. Okay, and the voltage is 10. So now if you this is the same voltage on the resistor R. So you know, can you find the value of R? For sure. Why? Because you know the power is V square divided by R. Now you know the maximum power, and then you know the voltage, you should be able to calculate R. Okay. So now I have two values for resistors. One can achieve the condition of 50, limit the current. The second one can achieve this condition. Then which one I have to select? For sure, you have to select the bigger one, because the bigger one, it's going to achieve both of them. That's why here in this one, I'm telling you, find the larger of the above two values. So you need to calculate these two values, and then you have to find the larger. And then the next task, after you know the largest one, you have to search in your kit. Okay, I have posted the all values of resistors you have in your kit. So you have to find in your kit a value that is equal or even large, a closest one to the value you have here. Okay, because I may have some value for resistor or for a resistance, and may not find it my kit. It's exactly the same value. It doesn't need to be exactly same value, but again, try to find the closest value, either equal or are larger than this one. Okay. This is you have to do in the pre-lab. So what you have to do in the pre-lab, number one, you have to use Ohm's law to calculate what resistance to achieve the first objective. Number two, you have to use the power V squared divided by R to calculate the second one, and then you have to see which one is bigger. Okay, and then try to find in your lab kit a resistance that is either equal or a little bit larger than the value you have here. And this is the one, this is the resistor you are gonna use. You are gonna use here. Yeah, this is the resistance R here. Okay. What about what resistor I have to use here? Because I told you guys, here you are gonna, one time you are gonna use a resistor, one time you are gonna use an LED, and then photocell. Okay, so here also in the pre-lab I told you here in this part. Now what about DUT? Please don't be confused between DUT and R. Here in this lab, we are interested to test or to know if the DUT is linear or not. Okay, R is just used to limit the current. Okay, limit the current. Okay. So anyway, so here I told you just pick up any random one. Okay, doesn't matter, because again the relation should be the same. Whatever the value for this relation should be the same. So I told you to select any random one in this range, okay, and then use it in the lab, okay. That's all what you have to do in the pre-lab. Now let's go to the yeah. So the second thing here, the second device you are gonna use, we call it LED. This one here, or light emitting diode. For sure, you are in the future you will learn more details about it, but all what you can know now is just you this one. Okay, I think I have an important picture here. Yeah, look here. This is the symbol of the LED. So LED is a semiconductor device that emits light when the current flows in forward direction. So when the current flows in the forward direction, it's gonna emit light. But when it is backward direction, no, it's off. You see what I'm saying? That's why we have two different terminals here. This terminal here we call it anode. This terminal here we call it cathode. And when the voltage of the anode greater than the cathode, current is gonna flow in this direction, and then it's gonna emit light. So you will see light. But if the cathode is greater than the anode, okay, so for sure no current will flow this way, because you can see this one can only current can flow in only one direction. But if you change the polarity, or this one cathode is greater than anode, this one off. Okay, so now given this device, given the element here, how can you determine what is the anode, what is the cathode? Very easy. Look here. This is, the long one here. This is anode here. Okay. The smaller one is cathode. Okay. Be careful. Don't connect this one. If you take this one and connect it directly to the voltage supply, 100% you will burn it out. That's why we need to limit the current, because too much current will go to it. That's why you need R, the value of R, to limit the current. Anyway, so I have a very good tutorial here. I want you to watch it. Okay. So I'm writing here, the longer leg is a positive or anode. Again, you can see this one like an arrow, as you see an arrow, because current can only flow in one direction. It cannot flow. So if this voltage anode is greater, current is gonna flow, and then it's gonna turn on. You can see the light or emit light. But if cathode is greater, current is gonna block, no current, open circuit. Okay. The second one here is photocell. Okay, number one, this is how it looks like. Okay, what is the photocell? Photocell is actually, or photoresistor, this is another name for it, a device whose resistance, it changes with the amount of light falling on it. So look, so that means in bright light, its resistance decreases. So this device, the value of the resistance of this device depends on the amount of light falling on it. Okay, the more light, that means lower resistance. Okay, for sure, something like that we can use it like a sensor to see if it is we in the more, if there is a light or dark, and so on. We use it in our life in many things. For example, if it is dark, you can do something. If it is light, if there is light, you can do something else, and so on. Anyway, also I give you here a link so to know more about this device. Okay, guys. So now we are gonna go to. So these are the three devices and then if you go to the lab here, okay. Yeah, so here in this lab we have three parts, part 1, 2, 3, 4. Okay, 4 parts. In the first part here, I want to find the relation between I and V for a resistance, normal resistance. Okay. And all what you have to do here, again, guys, I'm repeating it because it's very important, very serious. Here in the pre-lab, you need to calculate the value of R. Once you put R, the same R, we are going to use it for the three different devices. So now here, we are going to put a resistance here, okay? And now we are going to change the voltage here, okay? By changing the voltage, we are going to see different voltages here. By the way, the voltage here in DUT doesn't equal VS for sure, because there is a voltage drop here. It's not the same. Okay, that's why I want to measure the voltage here, and I want to measure and the current as well. Okay, so it's not the same. Like, be careful here, because in the past some students got confused here, and they took they took so you have here the voltage of the supply. It's not the same like this one. Why? Because there is a voltage drop on the resistance here. Okay. So here, let me go to. So here I explain in details what you have to do here. So again, after you connect the circuit, all what you have to do here, you have, yeah. So you have to change. You have to change from 0 to positive 10 volt, and back from negative 10 to 0. Okay. So that means you have to change the voltage from negative 10 to positive 10 in a step of 2. Okay, and every time you change the voltage, that means 0, 2, 4, 6, 8, 10, and also you can go to the other direction as well. So, and there is a table here. You have to put the results here in the table. There is a table here in data and analysis. You have to put the current and the voltage here, because after that's what I need to measure, right? Because after I draw the relation, I can tell if this device is linear or not. Okay, so I'm telling you here something you need to consider. You don't. So if you change, for example, 0 to 10, okay, how can you change? How can you go backward from 0 to negative 10? There is a small trick you can do, okay? The small trick you can do is to obtain negative voltage, turn the voltage down to 0, turn off the power supply, and reverse the terminals, the leads you are using. Just reverse them. So let me clarify this point. So look here. Yeah, you can see here, guys, this is a positive, this is a negative. Is that okay? So now it changed from 0 to 10 steps of 2. Okay, and now it changes them. So this one here should come here, and this one here has to come to here. Okay, by doing that, the voltage here became negative voltage. Okay, it's like exactly, it's like here, this one positive becomes here, negative becomes here. Okay, so all what you have to do, you need to change. Positive here has to negative has to come here to connect it to R. Positive here has to come to this one here, and then you it changes the voltage again from 0 to 10, but this time it's going to be negative 0. It's going to be 0, negative 2. Everything is negative until negative 10. Okay, by this way you have you measure voltage from negative 10 to 10, and you measure current as well. Okay, now for the LED, okay, it doesn't matter how you connect it, because we are gonna do the same thing you did here. However, I'm telling you here, you need also to record if there is no light at all, or if it is dim, or if it is medium, or if it is bright. You should notice, as I told you, in one direction, because you are going to change something here. So here, when as I told you, this is okay. Let me come here. This is the anode, this is the cathode. So in one direction, when this is greater, so positive, when this one is greater than this one, you will see light. But in the other direction, when you go from 0 to negative, there is no light here. Okay, because current can flow in one way, it cannot flow in the other way. Okay, so again, it doesn't matter how you connect it. However, I'm telling you, you have to be careful, because don't exceed. Once you see the current is greater than 3 milliampere, don't increase it more. Don't increase the voltage more. Okay, so once you find the current 30 milliampere, because more than that, you are gonna burn this LED. Okay, so again, here you need to do the same steps, exactly same steps you did here. Okay, it doesn't matter how you connect it for direction, because in one direction you should see current, in the other direction here, I mean, for example, from 0 to 10 you may see current, from 0 to negative 10 you may not see current, or sorry, you may not see light, or maybe the opposite based on how you connect it. You see what I'm saying? So still okay. That means, for example, from 0 to 10 you may not see light, but from 0 to negative 10 it's okay. You may see current, okay, based on how you connect it. Doesn't matter. What's really matters here is in one direction, or in one polarity from 0 to positive. For example, if you see current, the other one you should not see current, light, okay. Anyway, the last part here, we are gonna repeat the same steps. We are gonna use the photo cell, but when I use this photo cell, I'm gonna use it to the one dark, a dark one is illuminated. So how can you make it dark? As I told you here, you can put some material on the photo cell just to make it dark. In the other one, you don't do that. So here we are gonna record it twice. One time when it is dark, the other when there is no light hitting the photo cell, okay. Again, but this time be careful here in this experiment. I'm telling you here in these two experiment, I told you should be from positive 10, positive 10, negative 10. But here I'm asking you to limit it to 5 volt. So from negative 5 to positive 5, because greater than that you may damage the photo cell, okay. That's it. And then for each one of them, if you come here, you have a table. Just fill all what you have to do. Yeah, you have a table for each one from here. Okay. So for each one here, guys, I'm telling you, after you get the measurement, all what you have to do, draw the relation, and then I'm asking you, is that linear or non-linear? That's it. Same thing here for dark. Same thing for LED. Same thing here. Okay. The last thing here, as usually we do, this is deliverable. Okay, this should be in your report. Okay, so here I give 12 point for the pre-lab. So if you don't do the pre-lab, as I told you in the lecture, if you don't do the pre-lab, okay, and even if you put, you are gonna get 0 in this part, even if you put it in the final report. So the TA will come and check, have you done the pre-lab or not? Okay, as you see it, you cannot start the experiment if you don't do the pre-lab. Okay, so if you don't do the pre-lab, you will lose this part, even if you put it in the final report. Okay, guys. Anyway, good luck, and wish can be easy for you. Okay, bye.